Today we're going to be talking about section R.3, polynomials. All right, first thing I would like to talk about are our properties of exponents. We have a few of them. It's not that important that you remember the name of them, it's more important that you know how to use them. So the first property is called the zero power property, which says that anything to the zero power is 1. Next property is called the product property. Product property says as long as you have the same base and you're multiplying them, you add the exponents. On the other token, the quotient property says if you have the same bases and you're dividing them, well, multiplying and dividing are kind of opposites, right? So if you're dividing, instead of adding the exponents, you're going to be subtracting them. Next, we have what's called the power property. Power property says when you have a base to a power raised to another power, you multiply them. Fifth one is called a product to a power. So it's kind of like the product property and the power. So what happens is if you have two bases raised to a power, what you do is you could distribute this as long as you're multiplying the bases on the inside. If that was addition or subtraction, you couldn't do that, but because it's multiplying, you are allowed to. So this would be a to the xm power times b to the my power. And we'll see examples with numbers later. Property number 6 is a quotient to a power. And this is similar to the last one we just did, but if we have a quotient and we're raising them to a power, again, we could distribute that power as long as the inside's not over addition or subtraction. So this would be a to the xm divided by b to the ym. And then our last property is called the reciprocal property. The reciprocal property says whenever you have a negative exponent, you take the reciprocal and it becomes positive. Now what reciprocal means is you could put this over 1 and just switch its position. Reciprocal just means you flip the numerator to the denominator or the denominator to the top. So for example, just with this one real quick, if we had like x squared over y to the negative third, well, we want this power to be positive, so let's just bring that to the top. Nothing happens to the x squared, but y does become y to the third. So let's take a look at some examples. I'll ask you to simplify. Let's say 5 to the third to the second power. Well, 5 to the third is 125. I mean, we could do 125 to the second, or this is just a power property. 3 times 2 is 6, right? So, I mean, that would be a good enough answer for this. What about if we had 5 to the third times 5 to the second? Well, that would really just be 5 to the fifth. Let's take a look at some variables now. What if we had 2 to the fourth, x to the second, all to the third power? Now there's no addition or subtraction on the inside, so we are allowed to distribute the exponents. This could be 2, 4 times 3 is 12, 2 times 3 is 6. What if we had 2x over y squared, all to the negative second power? So sometimes we use a combination of properties. For this, I'm going to distribute this negative 2 to each of these powers up here, and to this 2, so that would be 2, 1 times negative 2 1 times -2 over y to the -4th. Now you can see we have a lot of negative powers. So the way that we handle negative exponents is we just switch their position. I'll bring that down, I'll bring this down, and I'll bring this y to the 4th up. So we have y to the 4th over 2 squared x squared. And then our last one, what if we had 3x to the -2nd, y to the 5/3 over 2y to the pi power, all to the 0. So this one's a little tricky, but anytime you see 0 as an exponent, that makes things a lot easier. This 0, anything to the 0 power is 1, right? So that's all the answer is. Next, let's talk a little bit more about polynomials. Now what a polynomial is it's an expression whose variable powers are whole numbers. Okay, and poly usually means multi. Meal means term. So just so you know, kind of the word we're talking about, that's where the meaning comes from. When we talk about a degree of a polynomial, that just means the greatest sum of any term's variable powers. And we'll talk about this in a minute. Okay. So first thing let's do is let's just make a chart. And with the chart, we'll be able to classify polynomials. And we'll be able to classify polynomials based on their number of terms and on their degree. So in this chart, let's have 0, and we'll go up to 3. All right, so for example, if we have no variable terms, technically that's just called a constant. So let's move on to column number 1. If we have one term, that's called a monomial. And if the power or the degree is 1, that's called a linear expression. If we have 2 terms, that's called a binomial. And 3 terms is called a trinomial. Now, if the degree is 2, that's called quadratic. And if the degree is 3, the highest power of the expression, that's called a cubic. So let's take a look at some examples, and we'll classify them based on how many terms they have and their degree. So what if we just had the number 2? Or we could even just write that as 2x to the 0 power. Because we know x to the 0 is 1, right? So 2 is really x to the 0 power. Now, there's one term, right? 2 just by itself is called a monomial. But it's actually just a constant. So we could say it's called a constant monomial. Constant because the variable power is 0, and a monomial because it's just one term. What about if we had something like this? Let's say we had 2x to the second minus 3x plus 4. Now, based on the number of terms, there's 3 terms, so we would call this a trinomial. But what's the highest degree here? Well, the highest degree is 2. So if you look at your chart, a second degree is called a quadratic. So this would be called a quadratic trinomial. Okay. How about something like this? What if we had 3x to the second minus 2 over x to the 3? All right. Well, really, this is just 3x to the second minus 2x to the negative 3. And we run into a little bit of a problem. This wouldn't be called a polynomial. If you remember back to what we said, a polynomial is an expression whose variable powers are whole numbers. We talked about this in the last section. A whole number would be starting at 0 and then going up to be 1, 2, 3, right? Negative 3 is not a whole number, so this is just not a polynomial. Well, maybe we'll try one more. Let's take a look at this one. How about 2 to the second, x to the second, y to the third? Technically, it's just one term, right? So it's called a monomial. What separates terms would be a positive or a negative sign, plus or a minus. The question is, what's the power of this? What's the degree of this monomial? Well, going back to what we said in the notes, we said that a degree of a polynomial was the sum of any term's variable power, right? The greatest sum of any term's variable power, which is why here we use 2, right? 2 is bigger than 1, so we look at the highest power. But for this, we just have a single term. So would the answer be 7 or would it be 5? The answer is 5 because we only use the variable powers. So really 2 plus 3 would be 5. This would be called a 5th degree monomial. So I hope that's clear on how to classify a polynomial based on degree and its number of terms. Next, let's talk about how to add and subtract. And generally what you want to do when you're adding and subtracting polynomials is we just distribute and combine like terms. So for example, if we had a problem like this, negative 3m to the third minus 8m squared plus 4. And we're subtracting m to the third plus 7m squared minus 3. Well, we could distribute this negative 1 technically in front, and then we'll just combine our like terms. If there's no number in front of parentheses, you could always just put a 1. But if we distribute, we'll get negative 3m to the third minus 8m squared plus 4 minus m to the third minus 7m squared plus 3. Like terms mean they have the same exponent and same letter, so this would be minus 4m to the third minus 8m squared minus 7m squared is minus 15m squared. And then we have 4 plus 3 is 7. That would be how we combine polynomials using addition or subtraction. Next is called multiplication. So how we multiply polynomials. We are just going to distribute using our properties of exponents. Some teachers use the word FOIL or the acronym FOIL. FOIL stands for first, outer, inner, and last. That's a way to distribute binomials. So let's take a look at some examples. So we had 2x plus 1 times 3x minus 2. We'll distribute the first terms. 2x times 3x is 6. X times x is, you add the exponents. So let me show you all the steps, at least for this first one. 2x times 3x plus 2x times negative 2 plus 1 times 3x, and then plus 1 times negative 2. Well, 2 times 3 is 6, but x times x is really x to the second. Minus 4x plus 3x minus 2. Combining our like terms would be 6x squared minus x minus 2. That's how you multiply polynomials. So what if you had a binomial and a trinomial? Well, we just do the same process. So 2x plus 1 times 3x squared minus 2x plus 1. We'll multiply the first term times everything in the second group, second term times everything in the second group, and then that's what we're doing, right? So 2x times 3x squared times negative 2x and times the 1. So 2x times 3x squared is 6x to the third minus 4x squared plus 2x. And now we'll distribute the 1. 1 times 3x squared, 1 times negative 2x, and then 1 times 1. Combining our like terms, we get 6x to the third minus x to the second. The x's actually cancel. Then we just have the plus 1. It's not harder, there's just more numbers to distribute. All right, so one of my pet peeves here is when we have something like this. Say we had 2x plus 1 to the second power. Well, we learned using the properties of exponents that we can only distribute this power if there's multiplication or division. You can't do that over addition. So the way we have to do a problem like this is we do 2x plus 1 times itself. So 2x times 2x, 2x times 1, 1 times 2x, and then 1 times 1, which gives us 4x squared plus 4x plus 1. Okay, and then we'll do one more similar to this. What if we had 2x plus 1 to the third power? So let's write it out. We're not going to distribute the 3 because we can't do that over addition or subtraction. Well, the way that we do this is we just do one step at a time. We don't try to do too much all at once. So let's just distribute these. We'll get an answer, and then we'll distribute it with the last term. We already know what the 2x plus 1 times 2x plus 1 is. We already did that, but I'll just show you all the work here. This would be 4x squared plus the 2x plus the 2x plus 1 times 2x plus 1. So this is just 4x squared plus 4x plus 1 times 2x plus 1. We'll have to do the same thing now. Let's multiply the first term times everything in the second group. 4x squared times 2x is 8x to the third plus 4x squared. 4x times 2x is 8x squared plus 4x. And now we have this last term to distribute into that second group. So 1 times 2x is 2x. 1 times 1 is 1. So we just get 8x to the third plus 12x squared plus 6x plus 1. All right, so hopefully you followed those steps. I'll just make sure I did everything right here. Combine my like terms. Yep. All right, so now let's finish up with dividing. So we talked about how to add and subtract polynomials, how to multiply them. Now let's talk about how to divide polynomials. Okay, and really there's two different ways we could divide. One way to divide is if we're dividing with monomials. So let's call it a monomial denominator. So what we could do for a monomial denominator is we could break everything up. So let's say we had 3x squared y to the third plus 6x y to the second minus 12 divided by 2xy. I'll just use our properties of exponents we already talked about. I'm going to separate this, 3x squared y to the third divided by 2xy plus 6xy squared divided by 2xy minus 12 divided by 2xy. And we'll just go step by step. 3 divided by 2 is just 3/2. We don't really use decimals in this class or beyond. X squared divided by x, we subtract them. It's x to the first, y to the second. Moving forward, 6 divided by 2 is 3. 1 minus 1, remember we're dividing using the quotient property, is just x to the 0, which is just 1. So I mean these really just cancel. And then we get y to the first minus, well, 12 divided by 2 is 6, but we don't really have anything on top with the x and the y. I mean, you could put x to the 0 and y to the 0 if you want, but 0 minus 1 is just negative 1. 0 minus 1 again is just negative 1. So let's clean this up. As far as what our final answer would look like, we don't usually write like fractions and non-fractions, so I mean, this is fine. Some people accept this, but you should know another way to write that is we could put the x over 1, the y to the second power over 1, and we could write 3xy squared all over 2 plus 3y. And then for the second group, we have the 6, right? So we could put minus 6, but we do have negative powers. So remember what we said with this. We actually put those in the denominator. So this would be the best answer. That's how we divide by a monomial or a single term polynomial. The second thing I want to show you is using long division. Generally, we use long division if we're dividing by a binomial. And let me show you. You probably learned this when you were in second grade. My second grade teacher was Miss Migliori. And I had a hard time with this, but she was a really good teacher. She was patient with me. So let's say we just had 175 divided by 2. What you would do, you would write it like this, where you have your dividend and you would have your divisor. You're dividing by 2. And we say that 2 doesn't go into 1, but it goes into 17. And 2 times what number gives you 17? 8 gets you close, and then you do 8 times 2 to get 16. We always subtract these numbers. Okay, so that gives us 1, and we bring down the 5. 2 times what gives you 15? Well, 7 gets us close. 7 times 2 is 14. We always subtract these numbers, and we get a remainder of 1. Now the way that we write our remainder, we don't really want to use decimals. We always write the remainder over the divisor. So let me write that out here. This is the remainder over the divisor. Okay, so let's take a look at what that looks like with, algebra. So what if we were doing 2x squared minus 3x plus 1 divided by x plus 2? Okay, Well, we'll write the divisor. We'll write our dividend. And what we're going to do is we're going to figure out x times what gives us 2x squared, just like we did over here. 2 times what gives us 17. Well, x times 2x gives us 2x squared. It's the same thing as before. 2 times 8 gives us 17. X times 2x gives us 2x squared. Now we're going to multiply 2x times x and 2x times 2, just like we did 8 times 2 here. Well, we're going to do 2x times x and 2x times 2. But we have to remember to subtract them. So what we wind up getting is we get, this would just be, let me just make sure I change the color here. These would cancel, as they always do, right? Negative 3 minus 4 is negative 7x, and we bring down the next term. So x times what is negative 7x? The answer is negative 7, and we're going to multiply negative 7 times x, negative 7 times 2. So negative 7x, and then minus 14. But remember, we always subtract. So we're subtracting a negative 7x. We're subtracting a negative 14. So we get just 15. There's nothing to bring down. So the way that we write our answers is we write plus the remainder over the divisor. This would be our final answer. All right, we'll do one more. One thing I just want to point out when you're dividing with polynomials is if you're missing a term, we use 0 as a placeholder. And you'll see why in this next example. So if I was going to ask you to do 3x to the 4th minus 2x squared plus 3, and we're dividing by x squared minus 1. Let's write it out. But you can see that we are missing some terms. So like there's no x term. When I say missing a term, that means like in descending order. So really what we want is we want to say x squared plus 0x minus 1. You have an x to the 4th, but where's the x to the 3rd? So we say 3x to the 4th plus 0x to the 3rd minus 2x squared. Well, there's no x to the 1st, so we put 0x and then plus 3. We always want to, like, descending powers of x need to have a term. So now that we have a position for all our powers of x, let's go ahead and multiply. X squared times what is x to the 4th? The answer is 3x to the 2nd. Now we're going to multiply by our divisor. 3x to the 2nd times x to the 2nd is 3x to the 4th plus 0x to the 3rd minus 3x to the 2nd. We have to subtract. We're subtracting a negative 3x squared, so that when you subtract a negative, it really is adding. So these would cancel, these would cancel. We just get x to the 2nd plus the 0x, and then there's 3 terms here, so we're going to need 3 terms, so I'll bring this down and I'll bring the 3. Okay, so let's do that same process over again. X squared times what is x squared? Well, the difference, it's just 1, right? 1 times x squared is x squared. 1 times 0x is just 0x. And 1 times negative 1 is just negative 1. But we have to always subtract. That's where some people forget. So I'm going to put a subtraction sign here. I'm going to put a subtraction here. And when we subtract the negative 1, it just turns into addition. So this cancels, we get a remainder of 4. So we write our answer, 3x squared plus 1 plus the remainder over the divisor. All right, hope that makes sense. Have a nice day.